for x is a real number, solve by non-calculus methods, and use Newton's method to see if you find the same solution. So we went through this problem over here, paper and pencil again. We got an answer, and now I want to look at Sage. All right, now before doing it, I want to just look at the problem and graph it out. All right, so let's go to the grapher application, and let's graph it out, see what it looks like. So I'm going to graph out the left-hand side, which is 1 over x to the x power. I get that picture there. And let me graph the right-hand side. And that's going to be 4 raised to the 16x plus 1. And that's raised to the 1/16th power. Oops. All right, let's take a look. All right, we're getting a picture over here. And someone says, what does the picture look like? Well, it looks like this over here, but I want to get a closer look at a particular region of it. And what I'm going to do is zoom in. Yeah, I'm going to just draw a little box around it. All right. Now, granted, I'm seeing 2 points of intersection over here. I'm just going to zoom in a little bit better. All right. So I'm seeing those 2 points of intersection. Let me just go back over the notes with you and emphasize we found 2 solutions to the problem. All right. One was 1/16 and one is 1/8. All right. Let me just go through that. Back over here. And I'm going to graph in 2 additional lines. I'm going to graph in x equals 1/8. All right, and you can see that's right where these intersect here. And let's type in 1/16 as well. That's right where these intersect. All right, so I'm going to say that that's fairly convincing. And what I want to do is, you know what, let's look at the graph that's presented to you. Yeah, same graph. All right. So anyway, I'm going to get Newton's method, and I'm going to go to Sage to do that. Sage is open. Let me clear the screen. And I'm going to reset. I'm going to define x to be a variable. And I'm not going to look at the code, but what I want to do is type this in. So how would you type it in? I'm going to type the function in f of x. And f of x is going to be equal to 1 divided by x to the x power minus, now I'm solving for 0 because Newton's method is going to be looking for the root. And I'm going to type in, let's see, 4 to the power. That's going to be 16x at 16 star x plus 1. I'm going to close the power out, close the, whoops, I didn't close the power out, and raise it to the 16th power. Part of using a computer algebra and learning how to do it. All right. The next thing I'm going to do is define this function, Newton's method. Now I know in my notes I have n down, but I'm just going to call it nm because I'm used to doing that now. And what is it going to be? It's going to be x minus the function divided by the derivative of the function with respect to x. All right. And then what I do is make an initial guess. And let's just go back, to the picture. And someone says, what would the guess be if I looked at the picture? Let me go back to the picture. Let me just look at this over here. I'm going to say it looks about, I don't know, 0.06, I'd say. All right, I'm going to make that guess. Oops, let's go back to Sage. X equals 0.06. And then what I want to do is I want to make another guess by using Newton's method. And I want to display it, see what happens. I get this number over here. Let me try it again. So I'm going to use that new x for another guess. And there's a slight change, not a big change. Slight change, not a big change. Slight change, not a big change. Wow, slight change, not a big change. This is getting a little bit slower. Wow. So I'm going to say, looking at it, this thing's probably going to be bouncing around a lot. I'm going to say it looks like the answer is, you know, that number there in terms of, I wonder what that number is. I'm going to say it looks about 0.0625, all right? Now, if I did 1 divided by 16, you're getting that number that we're getting there. Now, granted, Newton's method, it's bouncing around there. It's certainly because these functions are not easy to deal with. All right, let's do the next one. And I'm going to reset again. I'm going to do another guess this time, but I'm basically do the same thing. You know, x equals a variable. Whoops. I'm just starting again. F of x. Well, it's already typed in, so let's accept it. Newton's method again. Let's do a new guess. Let's go back to our picture. And there's a picture over here. So I'm going to say, looking at it, I'm going to say about, you know, 0.12. And I'm going to say that's my first guess. I'm going to get Newton's method to make another guess. I'm going to display it. And slight change. Let's do it again. So it's going to take that new guess and create a better guess, at least hopefully a better guess, right? Well, slight change. A slight change. Wow, that's right on the money, I think. Right on the money. It's not changing over here. And that's going to be 1/8. Let's do 1 divided by 8.0, just the same result. Okay, that's about it. Thank you.